Hello everyone, welcome back to my YouTube channel. In this video, we shall discuss on gas equilibrium constant Kp. So let's get started. The dissociation of sulfur trioxide into sulfur dioxide and oxygen is carried out in a control experiment. A sealed reaction vessel with a volume of 10 liter is initially filled with 0.8 mole of sulfur trioxide at 427 degrees Celsius. At equilibrium, the number of mole of sulfur trioxide, sulfur dioxide, and oxygen are 0.6 mole, 0.2 mole, and 0.1 mole respectively. Compute the equilibrium constant Kp for the reaction. To answer this question, the first thing that we need to do is we need to find what is the total number of mole. So total number of mole is equivalent to all the number of mole being summed together. So basically we have 0.6 plus 0.2 plus 0.1, which makes 0.9 mole. All this value can be get from the question, which is 0.6 mole, 0.2 mole, and 0.1 mole for sulfur trioxide, sulfur dioxide, and also oxygen. Alright, so next up, we are going to find what is the total pressure. In order for us to find what is the total pressure, we need to use the ideal gas law. So from ideal gas law, PV is equivalent to nRT. We can find the total pressure is equivalent to nRT divided by V. So your N is the total number of mole, which is 0.9. Your R is the gas constant, 0.0821. And your T, the temperature, is given, which is 427. So 427, you need to convert to Kelvin because of your gas constant. So your N is mole. Your gas constant should be in atm liter per mole Kelvin. So you are going to divide this with V, which is the volume given in the question, which is 10 liter. So now we are going to look upon the unit. So we have mole here, we can slash out with this. We have liter here, and then we have Kelvin, right? So you will end up having the unit for your total pressure will be in atm. So you have to plug in this in your calculator and you will get the total pressure is equivalent to 5.1723 atm. Alright, so since the question asks you to find what is the equilibrium constant, which is a Kp, so what you need now is you need to find what is the partial pressure for every gases that is included in the reaction. So I'm going to start with the sulfur trioxide. So the partial pressure for sulfur trioxide is equivalent to the total pressure times the mole fraction. Right, so the total pressure is 5.1723 and the mole fraction for the sulfur trioxide, so basically sulfur trioxide here, the number of mole is 0.6, so 0.6 divided by the total number of mole, which is 0.9. So you will get the partial pressure for sulfur trioxide should be equivalent to 3.448. So this one will be atm. So we are going to do the same for sulfur dioxide. So partial pressure for sulfur dioxide should be equivalent to 5.1723 times sulfur dioxide is 0.2 divided by the total number of mole is 0.9. So you will get the partial pressure for sulfur dioxide is 1.1494 atm. And lastly, we are going to do for oxygen partial pressure. For oxygen is equivalent to 1723 times is 0.1 divided by 0.9. So you will get the partial pressure for oxygen is equivalent to 0.5747. Right. So since we have calculated all the partial pressure, then only we can calculate what is the Kp for this reaction. Alright, so let's look again at the question. It says that the dissociation of sulfur trioxide into sulfur dioxide and oxygen. Therefore, when you want to write what is the balance equation, you need to follow this. Means that it is a dissociation of sulfur trioxide. So sulfur trioxide will be dissociated into sulfur dioxide plus oxygen. So now you need to balance out this equation. So since you have 3 oxygen here, but you have 4 oxygen here, the best thing that you can do is you put 2 here. So 2 times 2 is equivalent to 4, and then plus another 2 is equivalent to 6. So 2 times 3 is equivalent to 6, and you check back your sulfur. You have 2 sulfur at the reactant and 2 sulfur at the product. So this is a balanced equation already. So next up that you need to do is you need to find what is the Kp. So the Kp should be whatever in the product. So the partial pressure of oxygen times the partial pressure of sulfur dioxide. But sulfur dioxide you have 2 here, so this one you need to make to the power of 2 divided by whatever in the reactant, which is the partial pressure of SO3. And since SO3 also have 2 here, so you need to do to the power of 2. So now you just have to substitute with the value that you have calculated from here. Therefore, for oxygen is 0.5747 times for SO2 is 1.1494 to the power of 2 divided by 3.4482 to the power of 2. Therefore, you should get your Kp is equivalent to 6.3855 times 10 to the power of negative 2. So this is the final answer for this question. Thank you so much for watching this video from the beginning to the end. So I'll see you again in the next video. Goodbye.